I tried saving a ruined engine head using only carbide burrs. Here's what happened. When I first put this engine head on the bench, it looked completely finished. Not needs a little cleanup. Finished. I mean ruined. The combustion chamber was chewed up. One area had ugly weld buildup. The deck surface had scars and raised damage, and parts of the ports looked like somebody had attacked them with the wrong tool and then gave up halfway through. It was the kind of cylinder head most people would toss straight into the scrap pile without a second thought. But I wanted to see if I could actually save it using nothing but carbide burrs and a die grinder. No milling machine, no fancy seat and guide machine, no drill press rescue setup, just carbide burrs, patience, and a willingness to take this head apart, one damaged section at a time. The goal wasn't to magically make it brand new in 10 minutes. The goal was to see if I could reclaim a head that looked unsalvageable by carefully removing the damaged metal, blending the ruined areas back into shape, and cleaning it up enough that it could actually have a second life instead of becoming scrap. The very first thing I had to do was stop looking at it as one giant disaster and start looking at it as a series of individual repair zones. That's the only way a job like this makes sense. If you just grab a die grinder and start attacking random ugly spots, you'll destroy an engine head faster than you'll save it. So I cleaned the head enough to expose the real damage and then started inspecting every critical area one by one. I looked at the combustion chambers, the deck surface, the port openings, and the damaged threaded areas to figure out exactly what I was dealing with. Some of the damage was just raised metal and gouges. Some of it looked like old repair work gone wrong. Some areas had rough, torn material that needed to be blended. Other areas needed to be cleaned back to solid metal before they could even be evaluated. That inspection stage matters because when you're using carbide burrs on something this important, every cut needs to have a purpose. You're not just grinding metal away. You're deciding what material is bad, what material still matters, and how much you can safely remove without turning a bad head into a completely useless one. Once I had a plan, I picked the carbide burrs based on the shape of the damage instead of trying to force one burr to do everything. That part is huge. If you're trying to save an engine head, burr selection can make the difference between a controlled repair and a total mess. For curved chamber work and blending uneven damage, I used a flame-style or tree-style carbide burr because it let me work around the natural shape of the chamber instead of carving harsh flat spots into it. For tighter areas like port edges, damaged bolt hole lands, and narrow sections around rough welds, I used smaller cylindrical or pointed burrs so I could be more precise. If the head is aluminum, this is where an aluminum-cut carbide burr becomes a massive advantage because it clears chips better and doesn't load up as badly. If it's cast iron, the feel is different and the cut is different, but the principle stays the same. Use the burr shape that matches the repair zone, not just whatever happens to already be in the grinder. I started with the worst-looking high spots first because those are usually what make the whole part look hopeless. Old weld blobs, smeared aluminum, torn up metal, and raised gouges can hide what's actually underneath. So instead of plunging into the head and hogging material out, I used the carbide burr to shave the damage down in layers. That's the only safe way to do this. I kept the die grinder steady, braced my hands, and made short, controlled passes across the raised material to knock the peaks down first. The moment those high spots start disappearing, the whole repair changes because now you can finally see the true shape of the damage underneath. Sometimes what looked catastrophic was really just a raised mess sitting on top of decent material. Other times, knocking the high spots down reveals a deeper problem that still needs attention. Either way, That first step is about uncovering the truth of the head without making the damage worse. Carbide burrs are perfect for that because they let you remove exactly what's in the way without having to flatten everything around it. One of the ugliest sections on this head was in the combustion chamber, where the surface was rough, scarred, and uneven. There were sharp edges, ugly transitions, and damaged spots that would never be acceptable if this head was going back into service. That's where the Carbide burr really started proving itself. I switched to a flame-shaped burr and began working the damaged chamber area slowly, blending the high ridges and torn metal back into the natural contour of the chamber. And that's an important point. I wasn't trying to redesign the chamber or port the head into some race-only shape. I was trying to restore continuity. I wanted to eliminate the raised defects, remove any sharp edges that could create hotspots, and blend the damaged area so it flowed smoothly back into the original casting shape. I use the side of the burr more than the tip whenever possible because it gives a smoother, more controllable cut. I'd make a few light passes, stop, clean the chips off, inspect the contour, and then go right back in if it needed more. That stop-and-check rhythm is what keeps a repair like this from getting away from you. On an engine head, especially in a combustion chamber, you can't just keep grinding until it looks good. You have to keep comparing the damaged area to the surrounding chamber shape and remove only what's necessary. The ports were another mess. One section had rough damage and uneven metal around the opening, and there was no way I was going to leave it like that. But port repair is one of those places where people get into trouble fast, because the second they put a carbide burr in the port, they stop repairing and start enlarging everything. That was not the plan here. I wasn't trying to turn this into a full porting job. I was trying to save a damaged port without wrecking its geometry. So I approached the port like a contour repair. First, I knocked off any protruding or torn metal around the damaged area. Then I started blending the scarred section back into the original wall shape using light pressure and controlled movement. If there was a weld lump or ugly repair buildup, I reduced it slowly and feathered it into the surrounding material instead of cutting a giant hollow around it. I kept checking the roof, the floor, and the sidewalls to make sure I wasn't creating a mismatch or making one part of the port dramatically larger than the rest. That's the advantage of carbide burrs here. You can work right where the damage is and reshape only that section, instead of blindly removing material from the whole port. Then came one of the more delicate areas, the damaged threaded hole section. Around a bolt hole or stud hole, the metal is often crushed, mushroomed, cracked, or gouged from somebody trying to force a fastener out or repair it badly. Before you can even think about thread repair, inserts, or cleanup, you need to get rid of the broken, deformed material around the opening. So I switched to a smaller burr and worked around the damaged hole carefully, trimming away the ragged raised metal and cleaning the entrance back to something solid and uniform. This is not the kind of grinding where you just spin around the hole and hope for the best. Every pass matters because if you get aggressive and lean too hard to one side, you can distort the opening or weaken the boss around it. I was using the Carbide burr almost like a sculpting tool here, removing fractured material, re-establishing the shape of the whole opening, and cleaning it up enough that the area could later be repaired properly, instead of being left as a mangled mess. The deck surface was where I had to be the most disciplined, because this is the one area where a carbide burr can save a head or absolutely ruin it for good. A head deck has one job: seal. If you start casually grinding across it, you can create low spots, waviness, or sealing problems that no gasket is going to forgive. So I treated the deck damage differently than everything else. I wasn't trying to surface the head with a burr. I was only trying to remove material that had been forced upward. Things like raised gouges, smashed metal, burrs around damaged spots, or protruding weld material. I used the burr at a very shallow angle and made the lightest possible passes just to kiss the high spots and knock them down. If there was a gouge with a ridge around it, I targeted the ridge first. If there was torn metal standing above the deck, I cut only that raised section. Then I stopped, checked it, and made sure I wasn't turning a localized repair into a broad, low area. Carbide burrs are excellent for knocking down deck surface damage that sticks up above the ceiling plane, but this is where restraint matters more than speed. The point is to rescue the damaged area enough that the head can still be measured, checked, and resurfaced properly later if needed, not to hand machine the entire deck with a die grinder. As I worked from one repair zone to the next, the biggest difference maker wasn't the burr itself. It was the constant inspection between passes. I would grind for a short stretch, stop, blow the chips away, wipe the area down, and look at it from multiple angles before I touch the tool again. That sounds slow, but it's the reason the head didn't end up in worse shape than it started. Carbide burrs remove metal fast, and on a cylinder head you're often working dangerously close to valve seat areas, chamber walls, ceiling surfaces, and thin casting sections that do not give you a second chance. So after every few passes, I'd ask the same questions. Am I removing only damaged material? Am I still following the original contour? Did I just knock down a high spot, or did I start creating a low one? Is this area actually improving, or am I getting greedy with the grinder? That constant check and correct process is what turned the job from random grinding into controlled salvage work. And slowly, the head started changing. The ugly chamber damage began to look like a smooth contour again. The rough port area started blending back into a usable path instead of looking like broken scrap. The damaged threaded area cleaned up enough to be repairable. The deck no longer had those nasty raised scars and torn edges sticking up everywhere. It still wasn't a bolted-on right-now miracle part, and I'm not going to pretend carbide burrs replace every machine operation a cylinder head may need. But that wasn't the point. The point was to see whether a head that looked completely ruined could be brought back from the edge using only carbide burrs, and the answer was yes, if you approach it the right way. What saved this thing wasn't brute force. It was using the right burr shape in the right area, removing material in layers, and understanding that you're not grinding for speed, you're grinding for control. By the end of the repair, I had taken a head that looked like scrap and turned it back into something worth saving. The weld blobs were blended. The damaged chamber surfaces were smoothed and reshaped. The rough port sections were cleaned up. The mangled threaded area was restored to solid metal. The raised deck damage was knocked down carefully enough that the head could move on to the next stage of inspection or resurfacing instead of being written off immediately. And that's really the lesson from this whole job. Carbide burrs are not just rough metal hogs for generic grinding. In the right hands, they're precision salvage tools. They let you get into combustion chambers, ports, bolt hole areas, and irregular casting damage with a level of control that bigger tools can't match. If you know when to cut, when to stop, and when to leave good material alone, a carbide burr can absolutely be the difference between a ruined engine head and one that gets a second chance.
Thanks for watching. If you're looking for high-quality American-made carbide burr tools that are built to cut faster, last longer, and help you get the job done right, visit our website today. We keep our American-made carbide burr tools in stock and ready to ship, with same-day shipping available on orders placed before our daily cutoff time. Whether you're working on metal fabrication, porting, welding, automotive projects, or precision grinding, we've got the carbide burr you need. Visit our website and order yours today.